cloud. So I'm going to go ahead and get started. Thank you all so much for coming out to hear this talk. This was a talk that was originally scheduled for last year when all this craziness started. And so I was coming over and I was hearing about how we're at our 1-year anniversary on the pandemic. And I was like, oh, how appropriate, how terribly, terribly appropriate. But this is something that is a topic that is near and dear to my heart. I actually think that probably every other talk that I give could just be soil. It's really kind of the foundation of everything that's going on here. It's the foundation of what's working or not working in your garden, probably, to be totally honest. So I'm really excited about this. Just as a really quick little Zoom housekeeping, feel free to keep your video on. I don't think it actually affects bandwidth that much, but please do mute yourself throughout the talk. We will basically go through and do about 45 minutes of talk, take a break, answer some questions, do the second half of the talk, and then do the finish up and some questions as well. I will be sending out a recording of this as well as the PowerPoint slides, so no worries about that. And at the end, I'll have a link to a survey that if you could fill out, that would be super helpful. It really helps us gather information on how these talks are going. So yeah, with that, let's just dive right in, right? And oh, most important of all, Monica Mintz, Master Gardener Extraordinaire, is my wonderful helper this evening. She will be monitoring the chat. She will be kind of doing all these behind the scene things. This could not happen without her. So thank you, Monica. So a little bit of what we are going to talk about tonight. We are going to start with some of just the very basics of what soil is. So some of the different properties of soil in terms of physical, chemical, and biological. This is information that is the foundation of everything, and I think most of us haven't encountered it before. So this is something I think is actually pretty interesting. We're going to follow that up with a little bit about plant nutrients, nutrient cycling. How do you figure out what the nutrient levels in your soil are with soil testing? And finally, putting it all together. So you just might have heard a lot of chemistry, you might have heard a little bit of physics. How do you use that to actually grow what you want to grow, right? So what are the kind of really basic take-homes that you can use in your own garden? Before we dive right in, I do want to take a minute to just talk about this workshop series. This is the second talk in the Bull City Gardener series. Bull City Gardener is our workshop series this year. It has both online classes like this one you're attending, as well as in-person classes out at Briggs Avenue Community Garden. The full lineup is on the Durham County Cooperative Extension website. You can also check it out at that link below. All sorts of cool stuff. You can learn basically anything you want to learn. If you've missed one of the virtual classes, so say you're like, oh my God, I missed getting started with worm season vegetables. The link to that recording will be included in an email after this talk. And also you can always email me and I'll just send you those links. So if there's anything you miss, just let me know. For those of you who maybe this is your first time interacting with Cooperative Extension, welcome. I am the Durham County Cooperative Extension Horticulture Agent. Cooperative Extension is actually really phenomenal. It is a partnership between the land-grant colleges in each state and local county and state bodies. Here in Durham County, it's a partnership between Durham County, NCA&T, and also North Carolina State University. So this is really cool. It means we get the best research from the land-grant colleges and we get to get it out to folks so that they can actually use it. So we can always get you research-based answers to your questions. Here in Durham, the way we do that is through workshops, classes, field days. We love to send you like a written resource, right? Like we love to send you an in-depth document and also personal consultations. So whether it's on the phone, whether it's through email, or even in some cases, whether it's in person, we can come out and help you figure out what you're working on. Part of the really cool thing about Durham County Cooperative Extension is that in addition to some of the traditional cooperative extension programs like agriculture, 4-H, family and consumer sciences, I like to think of that as like everything you should have learned in home ec, but maybe didn't. We also have a really, really great, robust Master Gardener program, as well as Welcome Baby, which is support for children 0 through 5 years old, and Kids Voting, which is a really cool program that helps kids in Durham get involved in civic processes. If you have a bunch of gardening questions after this, you can always email me, but I will also say reach out to our Master Gardeners. So the Master Gardeners have a phone line, they have an email line. During normal times, they also have an office where they have walk-in hours. Obviously, that's not happening right now, but we're hoping to return to that someday, I guess, is the timeline for that, someday. But they can answer all your questions, and they have received extensive training. All of our master gardeners have gone through at least a 6-week training course on all things garden, specifically geared towards North Carolina, and they receive continuing and ongoing education as well. So if you think that's all well and great, but you're looking for even more ways to connect, the Master Gardeners run a blog. They have an active Facebook and Instagram presence, all sorts of different stuff. So maybe you can say, what are these folks about before you start sending them your questions? I tend to actually be a little bit shy, so I tend to snoop on people before I just start lobbing questions at them. So that's probably what I would do. Say you check out the blog, you check out the Facebook, you send them some questions, you get some cool answers, and you realize, oh my God, this is for me. You are in luck. This is a Master Gardener training year. We actually only train new Master Gardeners every other year because training is so intensive. If you're interested in learning more about that and attending an information session, check out this link. You can learn all about what it takes to basically apply to the Master Gardener program, hopefully get accepted. You'll get to go through that intensive training class, and then you'll get to be a full Master Gardener volunteer, and you get to kind of like do all the cool volunteer things that they do. One final plug for something that I think you will find extremely useful. This is the North Carolina Extension Gardener Handbook. It's available online for free. This is a book that was published just within the last couple of years. It was written exclusively for North Carolina, so it is very, very specific to the sort of climate and questions you're going to have here. And it's available in its entirety online for free. It's phenomenal. If you're like an old school textbook person, which like, I get it, you can also order a hard copy of it, but just the online resources are phenomenal. For reference, a lot of what we're covering today is chapters 1 and 2 of this book, right? So this is a really phenomenal book. If you're looking for more information, if you're looking for kind of even a deeper dive, it is a great place to go. And it is absolutely written to be readable, but it's still got kind of all the science, all the facts, all the research that you want. So with that, let's just dive right into soils, right? So, right, why do plants fail? I actually think this is really important for understanding why you might want to think about soil. So I think that there are a couple of major reasons that plants fail. One of them is what I would call the optimism of gardeners, right? I cannot be the only person who has attempted to try to put in beautiful full sun pollinator beds in shade, right? And you quickly see the plants fail. Or who struggled with soil issues, right? So this picture you see on the left, right? These beautiful full sun gardens, they require full sun. This is a major reason plants fail, is you don't meet your sunlight conditions properly. But the other big reason that I see plants fail is that this lawn over here, I have another screen over here. You'll see me look over here from time to time. This lawn over here, right? That's actually really hard to do here in North Carolina. And one of the reasons it's really hard to do is because our soil has basically been destroyed and doesn't want to support this sort of turf, right? You'll have compacted soil, you won't have good organic matter, you won't have good conditions, you won't have good water retention. And so basically this grass will fail and you will keep trying and keep trying and keep trying. But because the underlying soil condition has not been improved, plants will fail, right? And this is what I mean when I say it's really all about the soil, right? Soil is going to be your foundation, your building block. And hopefully by the end of the day today, you'll have a little bit of an understanding of how to improve your soil, because actually in this area of the Piedmont, it's pretty straightforward for most of us what we need to do. So thinking a little bit about what is soil, right? So dirt is that stuff that you get yelled in for dragging in from the back. Soil is the stuff we grow plants in, right? It's this kind of makeup of most of our ecosystems. And so soil can really be broken down into 2 components. A good soil is made up of space, right? So it's all this space between particles, and stuff, right? These are all of those stuff particles, I would call. And we'll talk a lot more about what's in the stuff and what's in the space, but think about it that way, that you really, really have to have both. Where does soil come from? This is kind of one of those classics of soil studies, right? There are 5 major factors that give rise to any soil. One is parent material, right? So this, and we're going to talk about this in the context of North Carolina a little bit later on. This is the sort of bedrock that soil comes from. And so a lot of times we think about that kind of picture of, there's solid rock, and then there's broken up rocks, and then there's soil on the top, right? Sometimes that parent material, though, maybe actually comes down from below or down from above, right? So maybe there were mountains that eroded and that's where that material came from. Sometimes it's blown in by wind, right? So some of the most fertile soils in China, for example, the lowest soils, that blew in, right? And that's the basis of their soil material. Sometimes it's deposited by water, right? So that parent material can come from any number of different places. But it really impacts the chemistry of that soil, right? Different parent materials, different rocks, different sources are going to have different chemistries. Climate, North Carolina here in the Piedmont, right? It is wet and it is warm. And that really, really, really impacts our soil. When you think about the age of a soil, it typically is how much weathering it's gone through, and it's not necessarily about how old it is. It's about how much wet and how much warm has it been exposed to. We'll talk about that more as well. Topography, right? So more exposed areas versus lower areas, those are going to impact soil formation. Biological activity, just all the critters in the soil, all the flora, the fauna, the microbiome of the soil, basically, that's all really going to impact how the soil forms. And finally, time, right? Soil just needs time to form. When you think about the formation of soil, you are thinking often on timescales that humans actually have trouble comprehending, right? This is actually a relatively recent discovery for us to really understand some of these soil processes, right? Humans have just started wrapping their head around them in the last couple hundred years. And that's because it was just inconceivable for us to think on such long, long, long time scales until folks started figuring these things out. Some of the major properties of soil we're going to talk about. We're going to talk about physical properties. So kind of how does it hold together? What is it comprised of? Kind of all of these different things like that. How do you get a good space to stuff ratio? Chemical, how does it interact with nutrients and other chemicals around it? And finally, biological, how are all those different critters and what I like to call worms and germs interacting with the soil? And what does the soil do for plants, right? So for a good soil, will provide water, nutrients, oxygen, and anchorage, right? So soils need that, or plants need that soil just to support themselves, right? And this is something that can seem a little bit counterintuitive, but the soil also absolutely provides those roots oxygen, right? Plants can actually drown if they don't have enough oxygen in the soil. A really, really excellent soil will also manage water flow for you. It'll break down waste and other pollutants. This is something that seems really obvious the moment you hear it, but it blew my mind when I first found out, right? So this is the whole concept behind a septic system, right? A septic system is the idea that you can basically put wastewater out into soil and the soil will clean it for you, right? And soil does that. Soil is an extremely good recycler and it's extremely good at breaking down different waste and kind of nasty products. It provides habitat and it also reduces water and nutrient inputs if you have a really good soil, right? So a really good soil, and we have the basis for a really good soil here in the Piedmont, will kind of take care of most things you need as long as you keep it healthy and you keep it provided for. And so in an ideal world, what does that really good soil look like, right? So a really good soil from most plants' perspective, remember all plants are different, they're gonna want slightly different things, but this is a good starting point. It's gonna be about 50% space, that's this portion on the top, right? And about 50% stuff. So the 50% space is going to be comprised of about half air and half water, right? So that space is going to be halfway filled with water, but the rest of it's going to be left open for air. The stuff is going to be about 45% mineral and only about 5% organic. I say only because a lot of folks seem to want to plant straight in compost. Don't do that. We'll talk about why. But actually here in North Carolina, 5% is like the holy grail, right? We say strive for 5. And if you spend all your time doing that in your garden, you won't accomplish it, but you'll get close and you'll have a much healthier, happier soil. So when we think about this mineral component, this is what really, really drives so much of what is going on with our soils. So the mineral components of soil can be divided into 3 things, right? It can be divided into sand, silt, and clay. So these are relative sizes for how big these particles are, but to think about it in kind of a more easy way, I guess I would say. So you can think about sand as something like a volleyball or a basketball, right? Quite large. Silt is then going to be something like a tennis ball, but not fuzzy, but size-wise, right? And clay is going to be something like a grain of rice. right? So not only is it significantly smaller, it's also shaped differently, actually, right? It's flat. It's a lot easier for them to stack up all on each other, right? So if you tried to pour water through a bucket or through like a bin of basketballs, it's going to move really differently than if you tried to pour water through a bucket of rice, right? The bucket of rice means the water is going to slow down. It's going to get kind of stuck there, and it's going to take a long time to get out, and it's going to stay wet for a really long time. Whereas the water moving through the basketballs or the sand is going to pour right through, and it's going to dry out pretty quickly again. And so for those who kind of want something to sink their teeth into, right, this is a picture where on the left, you can see just taken with kind of like a slightly magnifying lens, sand, right? And on the right, this is taken with a microscopic lens. These are clay particles, right? So sand can be somewhere in the range of about 2 millimeters, right? That's like, I can measure 2 millimeters, right? Like I can get a ruler and measure 2 millimeters. Right, whereas clay is going to be less than 0.002 millimeters. It's very, very small, cannot see individual particles easily. And it's these flat sheets often that really kind of stack nicely on each other and get really tight next to each other. And so if you think about this idea, right, of space and stuff, if all those little clay particles stack so tight on each other, that's not a lot of room left for space, right? Compacted soils. We'll come back to that. So it's actually really, really important. The ratio of sand to silt to clay that you have, it's going to dictate a huge amount of what's going on with your soil. And it's going to dictate what we call the texture of the soil. Texture is one of the 2 big words you're going to hear for how you describe a soil. And it really sets the stage for so much of what's to come. And so if you get curious, there's some really, really easy ways to actually figure out the texture of your soil right at home. One of my favorite ways to do this is something called the mason jar texture test. This is, I think, just like a cute technique. What you can do is you basically take a mason jar, you fill it a third full with soil, just go out, dig down, I would say probably somewhere in the 4 to 6 inch range in your garden. You know, you don't want a bunch of grass in there, you don't want a bunch of whatever in there. 4 to 6 inches down, fill that jar full, a third full with soil, add water and a tablespoon of powdered dish detergent. And that's to kind of break things up. Shake it up, right? So just shake that thing really good, make sure it's all broken up, make sure all the soil is broken apart. And after 1 hour, you can measure the sand being the largest particles, right? They fall out quite quickly. Silt is that medium-sized particle. It falls out after about 2 hours, creating this really kind of nice, clear layer. And clay will start falling out up to 48 hours later. Right? So clay is so much finer, right? The sand fell out in an hour. The clay is really, really fine. So it just kind of hangs out in the water for a long time before it starts settling out. So if you take this now and you've marked your kind of lines of where each thing is, we can see the total height, you know, is about 2¼ inches. You'll measure the sand line, you'll measure the silt line, and you'll measure the clay line, right? And I've just converted each of these into a percent of the total. Don't worry, you are going to get a full sheet on how to do this should you want to do it at home. We're just kind of going through the steps together so that you don't go, wait, what? You've actually seen it once before, right? So we know that this little mason jar that we collected, it's about 67% sand, about 22% silt, and about 11% clay. And that's what brings you to, and if you've ever thought about soil before, you have seen this before, right? The soil texture triangle. This is something that every time I see it, I almost actually get a little bit nervous. The reason for that being that graphs with too many lines kind of throw me off, but I will show you how to work through this. So if I know my percents, I can actually triangulate what type of soil I have, right? So starting with sand, I come here, percent sand, and because these numbers are going on this diagonal, see what I mean? I followed these lines up. So about 67%, that's sand. About 22% silt, right? So I come over here, I go up just a little bit over 22%. And finally clay at just about 11%. And if you ever get lost in how to use this thing, remember that the direction that these are going is the direction of line you should follow. And so you can see right where these three interact, you have a sandy loam, right? So this is actually super informative for what sort of soil you have. And you can tell also based on this that this did not come from around here, right? This is actually something that came from Clemson. If this came from here, We would be right here. We would be somewhere in this area. And so why does this matter so much? This is a great picture from right around here within kind of a couple county area. Red clay. So this really impacts what type of soil you have, the texture of it really impacts water permeation and retention. So how well can water get into that soil and how well does water get stuck in that soil? Aeration, so how much air can the soil hold? Nutrient supply and availability, and also soil strength. And by soil strength, I mean something like, imagine walking on the beach, right? Sandy soil, and how your feet sink in versus walking on our soil after it hasn't rained for 2 months. Nothing is sinking in, right? You are not getting through that stuff, right? It is rock hard. So, and that's really impacted by the size of particle in that soil. So some kind of general truths about clay soils versus sandy soils, right? So clay soils have a high nutrient holding capacity. They have a high water holding capacity as well. Those are for slightly different reasons. They're poorly aerated, so that's kind of the flip side of high water holding capacity. And they often feel slippery, right? So if you get one of these red clay soils on your hands when it's wet, right, it feels almost like slick. That's in contrast to sandy soils, right? So these have low organic matter and they have low native fertility, right? They just don't hold nutrients well. They also don't hold water well, right? The water pours straight through it, right? Going back to that idea of the water pouring through the basketballs. And they'll feel often very, very gritty to the touch. So part of what I really like about these two pictures that are behind this, just let me go back for a second. Oops. Right, this is our North Carolina kind of Durham area Cecil series. This is what our soils look like right around here. This is actually called the Fuquay series. So this is actually a soil right from not far away in North Carolina as well, right? And you can tell these are totally different soils. And to understand that, you really have to understand the soil history of North Carolina, right? And so this is something that I always really think is kind of interesting because it's crazy. So we're going to take just a really quick little North Carolina soil history break to put all of this in context. Right, so North Carolina can be broadly divided into 3 categories. It's divided into the mountains, the Piedmont, and the coast. And the difference between these areas is not just elevation, it's actually how and when those soils were formed. So the mountains formed 1.2 billion to about 300 million years ago. There were actually multiple events that formed the Appalachians where they were pushed up and then they would get worn down and then they would get pushed up again. They would get kind of tugged back and forth. And that was really during the formation and then the breakdown of Pangea, right? That magical thing where all of the different continents fit together. Following that, the Piedmont showed up on the scene about 300 million years ago. A lot of the Piedmont was originally what's called a volcanic atoll. That's like Japan, right? So it's when volcanoes actually push out of the water, they create these island ranges and they hang out, right? So a lot of the Piedmont was actually originally a volcanic atoll that slammed into the side of the continent, forming the basis of the Piedmont, right? After that, about 65 million years ago, the coast was deposited, right? So all of that was actually, we talk about different origins of parent material. The parent material of that actually came as basically sea level would rise and then it would go back down and then it would rise and then it would go back down. So over about, however many millions of years ago, ending about 65 million years ago, all of that material was deposited. And that's where those sands come from. And that's why actually the soils in these 3 areas are so different. Zooming in on the Piedmont slightly, this is actually, I think, super cool. And this is something it took me a while to fully kind of wrap my head around. And even then, geological time is a doozy. And sometimes it's hard to think about. But so when we think about the formation of the Piedmont soils, and specifically the soils here in Durham County, and what we like to call it the Triassic Basin, this is what happened when basically during all of these different massive geological events, what would happen is that we had these plate tectonics, right? So the plates that form the Earth's crust are ripping and tugging against each other. And as they're doing it, right where we are, if you kind of imagine that all of these little things are like stretch marks on the Earth's surface, right? So that you have the ripping and tugging of of the plates, and they open up these deep basins, kind of these rift areas that are lower. So just to the west of that, you have the Appalachians that are at that time much higher. And they are slowly eroding, right? So remember, the Appalachians used to be as high as the Alps. Now they're one of the lowest mountain ranges because they're one of the oldest mountain ranges. All of that material had to go somewhere. So what happens is that over time, all of that kind of sloughs off and is washed down basically into the Piedmont. And so what's really interesting about this is when you think about, right, that mason jar soil texture test, right? What happens? Well, the clay settles out first because those particles are the largest. Or sorry, the sand settles out first because those particles are the largest, and the clay is suspended for a long time and it takes a while for it to settle, right? So over the millions of years that the Appalachians are entering into this Triassic basin, you end up having areas of sand, areas of even boulders, right? You find a lot of boulders in our soil if you actually go start digging. And that's because those large particles settled out first and they basically dropped wherever they were. Which is why even now in Durham, if you go out, every once in a while, I'll run into someone's yard where it's like sand, right? You expect clay, you find sand. And that was because that was an area basically where all of the sand dropped out. The clay got distributed everywhere else, right? It hung out for the longest time and took the longest time to settle. So it's the most widely distributed, right? I love that. I think that's so interesting because it just gives me so much context for why you can go out and see a farmer's field, and the farmers around here, they will have pasture and it will have beautiful, beautiful, beautiful rock landscaping all around it. Those are rocks they pulled out of that field, right? Because they had to. This is an illustration from this wonderful article from Our State magazine that I'll send you guys. But so you can really just see, right? So over here you have these are kind of representations of all these different soil types. This is where you actually have some really good fertility from the unique ecosystems out here, but for the most part, right, it's going to be sand, it's going to be clay, and then in the mountains, because it's cooler, they're going to have higher organic matter. So what does this mean for us? It means we've got a soil type called altisols, right? So something kind of, I think, cool that soil scientists have done is they actually classify all of the world's soils into one of 12 soil orders. Our soil order, it's called an altisol, right? Fun thing I discovered while putting this talk together is that whoever wrote the Wikipedia article for altisol is clearly living in Wake or Durham County, and I would assume employed by NC State. So if you want to read a description of a soil that feels really relevant, check out that. So what is an altisol? It's a weathered clay soil. It's considered a very old soil. It's considered the second oldest soil possible because of that really high humidity, high temperature. Originally, they had a humus-rich top layer, right? So a really organic matter-rich top layer, and they supported forests well, right? Imagine before Europeans came here, especially most of North Carolina, not most, but a good portion of North Carolina, especially in the Piedmont, was covered by oak hickory forests, right? That is what our soil supported. You have rocks and boulders throughout and some sandy patches, right? And that's just because of how all that material settled. And finally, our climate just means it's hard to retain organic matter. All of the little critters that eat up organic matter, all of the bacteria, the fungi, everything that do that, they work faster when it's hotter, and they're happier when it's wetter for the most part, right? So when you have hot, moist conditions, it means they are just in overdrive all the time. They are churning through that organic matter all the time, and they are just eating it up. So it's really hard for us to maintain organic matter in our soil. So one of the major take homes though, right, is that we have a very, very, very clay soil here. And why does that matter? It matters because clay really, really, really impacts soil chemistry. And so what do I mean by this? One of the major ways that clay impacts soil chemistry is because clay particles, like a lot of particles, are covered in all of these little negative charges, right? So this is true for a lot of different types of soil particles, is that they have a lot of negative charges. Clay naturally kind of has even more of them. But the other thing about clay, right, that we talked about is that it's tiny. So if you imagine this soil particle and you cut it in half, right? Like imagine this is a grain of sand and you go ahead and you cut it in half. It's got negative charges on both sides now, right? You have increased surface area. As the particles get smaller, you have increased surface area. As you have increased surface area, you have more negative charges, right? The reason that matters is because most of our nutrients exist in the soil as charged particles called ions. So take yourself back to like high school chemistry, right? And you will remember there are cations, they are these positively charged ones, and there are anions, they're these negatively charged ones. I sometimes remember that a cation is positively charged because T and the positive sign look the same, like cat ion and the positive sign look the same. Occasionally because I think cats are positive. Kind of depends on how I'm feeling about cats at the time. But what really matters is that a lot of nutrients exist in the soil as charged particles, right? So they are these cations. And what we're really interested in when it comes to a lot of soils is their ability to really attract those positively charged particles, right? Because those are nutrients, if the soil can attract those particles and hold on to them, that's really, really good for our plants because it means there are a lot of nutrients held in that soil. And so what that's really referred to by soil scientists is the cation exchange capacity. And you'll see this referred to kind of the more you start reading about soil, the more you start thinking about soils, you'll see the cation exchange capacity or the CEC referenced. And it's the ability of a soil to hold cations as a nutrient reserve. This is what makes clays so amazing, why they're occasionally referred to as little nutrient bombs, is because the clays just, they hold onto all those nutrients and they really, really make them available for plants. They kind of keep them in the soil solution, right? So the soil solution is that water portion of the soil. And so the root hairs right here, right, they can't just reach over and grab a nutrient. They have to, like right off the soil, they have to get it from the soil solution. But if the soil is holding the nutrients, the water is there. And because of just chemistry and physics and all the way these things are interacting, right, the soil will occasionally let off nutrients. And if there are a lot of them available, it might hold on to them. And so it's kind of this constant change. And so it means that you have this kind of watery solution here that's got all these nutrients for the roots. And that's really phenomenal. This is why sandy soils were described as having low native fertility. It's because the water, the sand particles themselves are just not going to hold those nutrients that well. And so a lot of times they'll just literally wash out of the soil. Our clays will hold it super well. Just to kind of drive that point home, these are some of the kind of normal and expected ranges for cation exchange capacity for some of these different soil textures, right? Sands are going to be 1 through 5. Clays are going to be over 30. Our clays that make up most of our soils are actually very old and weathered, so they don't hold quite as much as this, but they still hold a really good amount. And typically a cation exchange capacity greater than about 10 means you're good to go. Right, and you will see this on your soil report, right? And we'll talk more about that. I want to leave this little like teaser down here about organic matter, but no, it's going to come back. But so this means that for the most part, our clay soils hold nutrients just fine. They are super happy about it. You often don't need to add micronutrients. They are in the soils already. So you might be thinking to yourself, okay, Ashley, what you're telling me is that my soil is fine. However, it doesn't always grow like things are fine, right? Like it doesn't always feel like things are fine in my yard. And so for that, I want to take us back one more moment to kind of North Carolina soil history, right? And soil history right in this area. Right, so this is from Eno River State Park. This is what this area looks like. My backyard does not have a river in it, but it also doesn't have this like beautiful lush growth in it all the time either, right? And so why is that? Well, our soils natively supported oak hickory forests, maybe even beech maple forests. So these are specific forest compositions. But what did we do to our soils here in North Carolina? We farmed them, right? We farmed them for tobacco. We farmed them for any number of different things. There was a really, really long tradition of farming in North Carolina that extends to this day. And this was very extractive. A lot of the soils were not necessarily managed properly during this, not through anyone's ill intent, just because we didn't know any better. And a lot of the organic matter was lost, right? So if you think about, not as much here, but across the globe in general, if you think about things like the Dust Bowl and all of these other things, these were issues of soils basically breaking down and you losing organic matter from the soils, right? On top of that, after our soils were farmed, they were then construction was done there. They were compacted, they were driven down, right? And so our soils made up of all those little platelets of clay looking like grains of rice were just pushed down as hard as they possibly could by all this heavy machinery, everything else, right? You can look at the soil in this picture and tell there's basically no topsoil left, but there is heavy machinery, right? So what are we left with? We are left with a typical Piedmont soil that is about 16% pore space, about 82% mineral, and about 2% organic. Remember, what we're looking for, right, is about 50% pore space, right? That's that compaction issue. That's that waterlogging issue we're all really used to. And we're looking for a soil that's about 5% organic, right? But we've got 2. So really what we've got is a highly compacted soil with little topsoil remaining, little organic matter remaining. So this is really where we start switching from thinking just about this mineral component to thinking about what is this organic component, even though it's much smaller, contributing to our soils. So let's take a step back. Let's think about where organic matter comes from, right? So organic matter starts as living matter, right? It starts as plants, animals. We'll focus mostly on plants. That then dies and turns into residue, right? So this is that stuff in your compost pile that's not quite composted yet, right? You look at it and you're like, that was a leaf, that was a twig, that was a chicken shell, like an eggshell, right? You still can tell what it is. That's when we call it residue. And when it breaks down, even past that residue portion, when it becomes unidentifiable, that's when a good portion of that enters into what we call humus, right? So humus is this wonderful stuff, right? It is so dark, it's very stable, it's very long-lived in the soil, right? So living matter exists for, I don't know, it's kind of an existential question, however long it lasts. Dead matter is going to last for, years. Humus can last for decades to centuries, right? It's very, very stable. It really exists in the soil for a long time. Humus, another thing that's interesting about it, I think, is that humus particles are so small that if you are working in soil that has a lot of humus in it, you will come inside, you will try to wash your hands, and you'll have trouble getting the dark off, right? And it's because the particles are so small, they're getting in between the ridges of your fingertips, right? Very, very small particles, often even much smaller than clay. And so when you lose all that organic matter, when you lose all that humus, your soil doesn't operate quite right anymore. And that's because we've been thinking about texture, we've been thinking about the mineral sizes. Now we're going to switch to thinking about structure, right? So I told you there are 2 big words in this talk. There's texture and there's structure. Structure is not just what the minerals are, it's how they organize themselves, right? So if you look at this great picture, you have a big sand grain, you have a medium-sized silt particle, and you have tiny clay particles that they don't even draw. Mixed in with that, they have organic material, right? So the organic material is able to actually coat those clay particles and keep them from just stacking so tight on each other. It's able to space them out just a little bit so that you have increased pore space, right? So that's the first thing that the humus is able to do. It's able to actually kind of start breaking the clay apart and allowing you to have more air and water in that soil. And what we're really talking about here is we're talking about soil aggregates. So an aggregate is that sort of clump of soil that you pick up, and it wasn't formed by compaction. It wasn't formed by you forming it into a ball. It was formed by nature, and it's in a really good kind of configuration. So this over here is what we describe as a blocky soil structure. No, this is a granular soil structure, sorry. And it's often soil, it's that really nice soil that you can find where it almost feels like cookie crumbles, right? It's got this nice kind of gritty texture to it, but it just holds together really, really well. That's the mark of a good, healthy soil. And so the way that organic matter helps with that is that more organic matter, more this OM you'll see me sometimes calling organic matter, leads to a better structure, leads to less compaction, better water infiltration, right? Because you have better pore space, better water movement, because the water can move through the pores, it doesn't just get stuck, and improved nutrient availability. We'll talk about that in a second. But the more organic matter you can get into that soil, up to about that 5% mark, the more it's going to break those clays apart and really kind of improve the whole show. As the soil gets healthier and as it has more organic matter, it attracts more soil organisms. This is really kind of where the magic starts. You typically don't need to add any of this stuff to your soil, nor will you even really be successful adding any of these critters to your soil. They will come when the soil is healthy, and they will kind of come in waves, right? So they're kind of the ones who will show up when the soil is almost healthy, up to the ones who are going to be kind of divas and only going to show up when it's really healthy. Many organisms can help plants grow can help plant growth and further improve soil structure. So some of these small things are going to help actually provide nutrients to the plant. Some of these big things like earthworms or even burrowing animals, right? They burrow through that soil and they create those bigger pore spaces, right? They create those even larger like tunnels, right? And water can move through those tunnels. All of that's really good. All of that's what you want in a good, healthy soil. And in case you're worried about attracting all these critters to your yard, both big and small, soil has a complex food web, right? And so for everything that shows up to hurt you, something else will show up to help you, and something will probably show up to eat that thing that's hurting you, right? So when you have this really kind of good, diverse ecosystem going in the soil, it really takes care of itself. And that sort of diversity is what you really want. One additional really cool thing, I think, that all of these soil organisms can do, especially things like the fungi and roots and microbes, is they actually help soil form even better, right? So we talked about humus, tiny soil particles, coating clays and forcing them to not touch each other. What happens then is that the root hairs go through, and the root hairs have all these like sticky substances that they give off. And those sticky substances help stick the soil particles together even better, right? And so they will form, this is one size, and then you can see it's actually just a zoom in from over here. This is an even bigger aggregate, right? And so those roots and the fungi and the microbes will give off sticky substances, they'll give off sugars, they'll give off all these different things that help stick the soil together even better and better and better, so that your aggregates are even stronger. And this is what takes clay into being soil, right? It's what makes it good. It's what makes it productive. It's what makes it not just get waterlogged and disgusting all the time. It's what allows it to give nutrients to your plants. It's what allows it to do all of it. And this is really all about getting organic matter into it. I would be remiss when I'm talking about soil organisms if I didn't give a special shout out to mycorrhizae. These are the fungal networks that exist in our soils. These are super cool because basically what they do is fungi, sometimes they're mushrooms, sometimes they're not, right? Not all fungi are mushrooms. They basically have set up a deal with the plants. And so what the fungi do is they give the plants water and mineral nutrients, right? So the fungi are really good at getting water, they're really good at getting nutrients, and the plants are really, really good at making their own sugars through photosynthesis. And so the fungi give nutrients to the plants, and the plants trade them carbon and sugars in exchange, right? And so this makes the plants far more efficient, makes them far more effective at growing in the soil. It can basically extend the root network of a given plant massively, right? So if you look at, this is actually more like the fungal network of this little seedling, right? So its little roots might only go this far, but that fungal network, when you start looking at it, it's much broader. And increasingly what researchers are coming to understand is that these fungal networks between plants, they interact as well. And so this is kind of a great picture from what's called the wood wide web. This is this idea that trees and other organisms are basically able to communicate even if their roots never touch because their fungal networks touch, right? And so this is kind of part of this idea of what's going on below the soil is massively complex, is ecologically diverse, is just really, really complicated, really, really interesting. And we're just starting to like scratch the surface. And so I would say dollars to pounds, if I had to do something, I would just try to make it as nice and lush and diverse as possible, because I don't even know what's going on down there, but I know I probably want it because this is how plants evolved to interact with the soil. And just coming back to this idea that we kind of planted earlier of cation exchange capacity. Remember I said organic matter is so small it gets stuck in your skin basically. Smaller particle, higher surface area, even better CEC, right? So the organic matter is what takes our good clays into being exceptional when it comes to nutrient capacity and nutrient availability for plants. So all of this to say, right, healthy soil is living soil. What you want more than anything else is you want to dig into your soil and you want to basically be inundated with worms and grubs and everything else like that, because that's how you know it's good and you know it's healthy, and it's the sign of success. Sometimes we will get calls from people who say, oh, I'm getting some sort of weird fungal bloom on my soil, and I go, great, it's alive, right? The vast majority of these things are never going to hurt you. They are just benefits, and it's how you know that your soil is alive and happy, so it's all good. So with that, We are about 50 minutes in, so I'm going to say that we should go ahead and take a little, maybe 10-minute break. Stretch your legs, get a drink, go to the bathroom, whatever. Monica and I will be here. We'll be looking at questions, but don't worry, we will not answer them until 7 o'clock. So feel free to truly stretch your legs.
Ashley, have you by any chance seen on Netflix the documentary called Kiss the Ground?
Yes.
Were you going to talk about that? No.
It's a secret admission of mine that I don't tell anyone. I don't like it.
That what?
I don't like it.
Oh. There might be things in it that aren't right or true or.
It's an interesting idea though.
Yeah.
Heard that.
I have no idea if, and they're only targeting the small, I don't even know how I got on the list for the thing. They're only targeting the small farms. But I'm not sure how far that's going to get you if you really think that the dust is, every year is by them tilling the soil.
Well, and we will talk about tillage. I think that the movie has some super interesting points, and I think it's got like a good heart. My objections were like, I have a hard time whenever anyone says a big fact and doesn't give a citation. That's just me, like that's my own inclination, which I'm sure everyone watching this is like, you haven't cited anything. Read chapter 1 of the North Carolina Extension Master Gardener Handbook. So anyway, but I will say that it's really interesting, especially being here in North Carolina, because we basically can't do carbon sequestration here. Like our climate won't allow it. Like I was saying, right? Like all the microbes are just going to continually release the carbon relative to places like the Midwest, for example, and especially the upper Midwest and kind of the breadbasket, where they could do really meaningful carbon sequestration there. But
so you think that the theory holds some merit?
Absolutely.
I mean, like I hope that it would.
No, the theory is totally sound. Yeah, I mean, my objections to that were more some of the way that they portrayed chemical inputs in agriculture and those sort of things. Just because like folks might have really negative feelings about that, which I totally understand, but there was also like a period in the world's history where we were like smart, good-hearted people were legitimately concerned how we were going to feed the population.
Oh yeah.
And I wouldn't like downplay that, like the level of fear that and like why we have agriculture the way we do. Like it's not a perfect system, but like it was not, I don't know. So no, the carbon sequestration thing is super interesting though, because if you think about like the massive amount of carbon that we're releasing into the environment is fascinating in and of itself, because even the reason we have things like coal is because there was a period in the Earth's history where plants took over the land before the decomposers could catch them. And so there were millions and millions and millions of years where plants were all over the land and they were falling and they were dropping and they weren't decomposing because the decomposers hadn't caught them yet. And that's why you have them turning into coal and other things, right? And so when you then go back and you dredge that out and you burn it up, you release all of this carbon that was historically never released in that way.
Right.
And if you took it out of the ground, it stands to reason there are ways to get it back into the ground.
Sure.
But yeah, I read that fact and it blew my mind. I was like, oh my God, that's why you used to have coal form and you don't have it form anymore, is because
now that's considering the fact that Tom actually we were for a while in raw minerals. That was coal when he worked for a steel company. That's really fascinating. I mean, I know a bit about coal, but I didn't know that.
It's the reason though, you're like, why did there used to be coal formed? But
well,
like
it's the whole more fossilized remains, but not in the formation that coal is. So
yeah,
that doesn't make sense. Wow. this being the more technical part of your, well, all of this is technical. It's definitely a deep dive. The 42, 43 participants have not had a lot of questions. So when everybody comes back in 6 or 7 minutes, there may only be a couple questions for you at that time.
Yeah, totally. Oh, this one's fun.
Okay, well, don't answer it now, and I'll read it to you when it's time to answer it. And I don't want any of some of those creatures in my soil, Ashley. You're not going to tell me that voles or moles are a good idea.
They're excellent aerators.
Oh, I get that. And really, I only care about my raised beds, which I was careful to put down, the 1 inch by 1 inch screening so that they couldn't come up in through the bottom of the bed.
Nice.
But that's it. That's, they can have run of whatever else they want, but I haven't had too much of that anyway. Moles or voles.
Yeah, I'm not surprised we don't have as many folks at this talk. I think people figure out that I will send out recordings and then they're like, I will watch that at my leisure.
Oh, well, I don't know. Does this count for something if you're a master gardener?
Education.
Education. Yeah. All right. I think your talk is great so far. I've really enjoyed it. It's wonderful to have a recap, even though I only learned this about 1.5 years ago.
Yeah, totally.
So this is great fun and something that I wish everybody knew more about. To me, the basics of everything are important so that you can move on from there, build on that, and soil is just not only amazing, but ridiculously important, the quality of the soil.
Well, and the truth is that so growing up, and I mean, it makes it sound like she's dead, but she's not. So my mother is a soil scientist. She has her PhD in soil science.
Wow.
And I just remember as a kid driving along and her yelling look at that rock formation, and I was just like, Mom, I can't with this, and I never I never understood why, right? And then or the big one was we lived in the Midwest where you have phrases I will never forget. Glacial erratics. Glacial erratics were the big rocks that you see, big boulders you see sometimes dropped in Midwest fields. And it's because when the glaciers were retreating, they were basically dropping these boulders that they had carried down with them. And
right.
So glacial erratics.
Okay.
And these are just the things that I have seared into my mind from childhood. And it wasn't until I took this position and I was like, I need to learn a little bit more about soil, that all of a sudden I would just call her up and be like, did you know about this? And she's like, I have been trying to tell you about that.
Right. Well, you've chosen to become your mother a little early, Ashley. But
it was bound to happen. There were worse people to be, but it was definitely it was a trip. It was a trip as soon as it started dawning on me, where I was like, oh, this is really interesting. I wish.
Oh, isn't it though? Wow, that is so cool. Your mom's a PhD soil scientist. The farmer where I buy most, if not all, of our meat and whatever vegetables of his I can get my hands on is a PhD soil scientist.
They're interesting folks. I mean, they are.
Yeah.
So she's a soil scientist, but she started out in geology, and they're a little bit different. And she's convinced that geologists are weird. And the more I hear about it, the more I'm like, they seem, because they think on this time scale that's so my background's in evolutionary biology, and that's a hard time scale to think on. But it is nothing compared to geologic history.
Yeah.
Where the mind cannot fathom the timescales we're talking about.
I can't wait till I run into a geologist. I, for the first time, have granite in my kitchen, and I'm so fascinated by the granite that, it's probably borderline obsessive. I'm like, wow, what is that? The only thing I can identify is the quartz, but it's it's natural stone. I mean, there's so much there that I know that I would like to learn about, but I want a geologist to come in and tell me, what is this? What is this? What is this?
Even just the idea of how that forms, right? The amount of pressure and the amount of churn that's happening to a rock. And you're just
well, and of course I love it, but I appreciate that if people are making a living out of this, and it is a natural product, that we are taking out of the earth. So I have concerns, but
They're like all
and I didn't do the whole thing in granite. So, you know, I drew the line somewhere.
well, I mean, they're beautiful products. I mean,
Some of
okay, so we are
more than others. All right, so if it is close enough to 7 o'clock for you, I would like to just ask a couple questions if that's okay.
sure. Yeah, knock yourself out.
All right, so it is 7. Anne says, my garden area is hard clay. In a raised bed, can you use store-bought bagged soil and bagged black cow mixed with a little of my clay? It is really difficult to break the clay up into pieces.
So we will talk a little bit about this in the second half, but just use bagged stuff with a little bit of compost. Don't even use your native clay. The native clay is really, really phenomenal, but for raised beds and especially edibles, there are reasons to think about using other things. So the bagged soil works well.
All right. And Mackenzie wants to know, can you identify and explain what each of the bugs/animals in the healthy soil picture do for the soil? Are they all beneficial? You're asking the wrong person, Mackenzie.
Yeah, I can get most of them. Can you see my cursor when I do this, by the way?
Yes, ma'am.
Okay, cool. So these guys, these fine cows, are dropping organic matter. I think is a polite way to put it. Probably still residue at that point because you can tell what it is. And so that's all incorporated. And if you look at something like this beetle right here, this was my comment earlier about beetles and about dung beetles. When you think of a dung beetle, typically you think of that beetle like rolling the ball of dung. The rollers get all the press. I'm over it. There are burrowers. So this guy you could say potentially is a burrower. And so what he'll do is he'll take the cow patties and he'll start actually burrowing them down into the soil and incorporating them that way, because that's where they lay their eggs, which is super useful. You have a number of different worms. They're creating these really, really nice open spaces. These are really like large pores, as well as grubs and everything else that as they move through the soil, right, are creating that open space. You have a mole or a vole. For those keeping track at home, moles eat meat. Voles are vegetarian, right? So the mole, if it's a mole, he's eating grubs. If it's a vole, he's probably coming up and eating the potatoes. So they're really cute and really cool until you twist your ankle in a hole. So not everybody likes them. If we want to interpret these as potatoes, right, and corn, then they're just adding roots and adding organic matter that way. If we instead want to interpret them as peanuts, they are actually have all these really interesting structures all along the roots, these specialized nodules where bacteria live that can actually pull nitrogen from the environment and add it back into the soil, which is why a lot of things like peanuts and other legumes are really awesome, is because they can actually add nitrogen to the soil.
Wow.
So,
all right.
Those are a big one.
Diane says that she filled her raised beds with a mixture of bagged garden soil, bark fines, compost, and turf face, which is calcined clay particles. Looks like kitty litter. Should I add native clay soil to the raised beds to hold on to nutrients?
No, I wouldn't worry about it.
Yeah.
And we'll talk about this in a minute, but remember those veggies you're trying to grow are not native. So they will be only somewhat impressed with our native soils.
She also says that she met a woman whose family manufactures clay kitty litter. Her job was to drive through the Piedmont to find the right type of clay deposits, which she tested by rubbing the clay on her teeth.
That's a beautiful story.
I don't think there's a whole lot. I mean, like there are things you can catch from the soil, but I'm not sure.
That's what your digestive tract is for, is to shut that down. I say
kill that up. All right. And one last one before you go ahead and get started into the rest of the talk. If I'm striving for a natural garden area where now fall leaves have fallen, what shall I do with the leaves? Are they to be raked up and stored in a pile or left to decompose? Oh, please let them decompose. And Ashley, it's on to you after you answer that one.
Yeah, so I like to let them decompose. A lot of times from the North Carolina Audubon Society, the New Hope chapter, which is our local chapter, that's the bird lovers, right? They have a Leave the Leaves campaign. Leaves not only add organic matter and carbon back to your soil as they decompose, but they also provide really good habitat for any number of small critters that like to hide in the leaf litter. I would absolutely leave the leaves if you can tolerate it. You can shred them up a little bit if you like, but even then, I literally just rake off my pads, leave them on my beds, and it works really well. And if you feel so moved as to mulch, you can just mulch straight over them. So if they really drive you nuts, you could rake them up and compost them on site, but I don't see any reason to rake up all my leaves to give them to the city landfill to go out and buy organic matter, right? Like I have organic matter falling from the sky. Why wouldn't I use that? So, all right. So we've covered some of the kind of soil basics is what I would call it. And now I want to transition over into getting the most out of your soil. So this is a great picture from the Ralston Arboretum over in Raleigh. I love this. It's absolutely beautiful. I think this is what we all kind of like want for our gardens, right? We want some place that's beautiful and lush and nice and pretty, right? And so in a lot of places in Durham, that's going to be a shade garden. So that's why I picked this picture. But this is kind of what we're really trying to do. And so to do this, we have to take all of these things we've learned about texture, and we have to take all these things we've learned about structure, and we have to put them together with what the plant wants, right? So the soil has got all these amazing things. We got to figure out how to make sure the plant is also getting really specifically what it wants. So just kind of a reminder about how plants do what they do, right? Plants are producers that capture sunlight and they turn it into sugar and carbohydrates, right? Plants are often the very first step in most food chains because they are the ones who are able to actually capture sunlight. And they do that using 17 essential nutrients. And so the primary nutrients are carbon, oxygen, hydrogen. Carbon, oxygen, and hydrogen make up about 94% of a plant's weight. And then the other three primary nutrients, which you're probably familiar with if you're a gardener, are nitrogen, phosphorus, and potassium, NPK, right? And so these are the three that plants get from the soil. The other three they get from other sources, from oxygen and from water, which is why they need both. But these are the three they get from the soil. So if you were with us for our getting started with warm season veggies class, you've seen this before, but I think everyone can always use a refresher on what nitrogen, phosphorus, and potassium do for a plant. So nitrogen, this is really what promotes green leafy growth. So this is kind of everything before flowering. It's all the vegetative growth. Some of the major deficiency symptoms, if you don't have enough nitrogen, are you'll have yellowing, which starts in the lower leaves, works its way up the plant. The plants will be stunted, they'll fail to grow, and too much can cause plants to shed flowers and not set fruit, right? So it'll basically be performing on overdrive when it comes to green leafy growth, and it just won't even want it to fruit. So this is really kind of what gets the plant green and growing. Phosphorus, on the other hand, is really all about root, flower, and seed and fruit development. So in this area, only apply phosphorus if the soil test indicates it, and it should be tilled in, not water soluble, because it's not water soluble, right? So if you put phosphorus on the top of the soil, it won't actually go into the soil, it'll just sit there and then it'll run off. So you actually have to till it in. Interesting, like soil history fact for North Carolina, the reason you do not apply phosphorus unless the soil test tells you you need to is because we have so much of what's called legacy phosphorus in this area that like it can be off the charts. So, right, so for a long time, farmers in this area were struggling to grow crops until they realized that if they just started dumping massive amounts of phosphorus onto the soil, their crops would really, really pick up. They would perform beautifully. They would do a great job. You had to do it pretty consistently for some reason. You'll find out the reason later, but you had to do it pretty consistently for some reason, and it meant that there was massive phosphorus buildup in the soil. We typically have a fair bit of phosphorus in a lot of areas. Because of that, it's that legacy phosphorus from the past 100 years. So just don't apply more if you don't need it, because phosphorus can really impact water. And so it's better just to like not add more if you've already got it. Finally, we have potassium. This is the other of the primary nutrients. It supports overall plant health and growth. It increases disease resistance, cold hardiness, and drought tolerance. It's also known as potash, and it leaches at a moderate rate. And when I say leaches, I mean, so the way that phosphorus will basically just sit on the top and not move down, potassium will move through the soil, right? It'll move and you'll lose it. So those are the primary nutrients. There are also secondary nutrients. Those are calcium, magnesium, and sulfur. And finally, there are the micronutrients, so iron, chlorine, manganese, boron, zinc, copper, molybdenum, nickel, and cobalt. So these 17 nutrients taken together are basically everything a plant needs to get going. These are also these are the ones it's going to need the most of. It's going to need a little bit of these, and it's going to need really trace amounts of these, such small amounts of these micronutrients that you'll almost never have to add them in our clay soils. The exception, because of the type of clay we have, because of the fact that we have an ultisol, there are 3 nutrients that we can be low in. Those are potassium, calcium, and magnesium, right? So potassium is one of the primary nutrients. You will notice that often our soils are low in potassium, and calcium and magnesium are secondary nutrients that often our soil is low in, but sometimes not. It just kind of depends. That's because oftentimes these are in lime products. So if people have been liming a lot, you don't have a deficiency anymore. So these are all of these different types of nutrients. And the interesting thing about plant nutrients is that they basically cycle through the soil and are made available to plants in a just multitude of different ways, right? So all of the different nutrients tend to have their own nutrient cycle. So they're broken down by different microbes, they leach at different rates, they move through the soil at different rates, they get stuck at different spots, right? They all are different because they're all different chemicals, right? So they go through many, many different chemical forms, but the majority of what you'll see is that you have some sort of organic matter residue, dead, dying stuff, right? That's left here. It gets taken down into the soil by water or by other movement, or maybe it comes up from the subsoil, from the rocks, right? It's actually rocks breaking down and coming up into the soil. And basically through a number of different nutrient cycles, it gets turned into a form that the plant can use to grow. And this is really important. Nutrients have to be in the right form for plants to use them, right? So oftentimes you'll have a nutrient that's available or that's present in the soil, but it's just not in a form that the plant can see, right? So it doesn't really matter how much is there if the plant can't see it, right? So this is why it's really, really important when we think about soil biodiversity to have as many different microbes, as many different worms and germs as humanly possible, because all of those different guys are doing different things to different nutrients, breaking them down in different ways. And so the more diverse ecosystem you have, kind of the better nutrients you'll also have. So one of the kind of major nutrient cycles you'll see, and I just want to use this as an example of how complicated nutrient cycles can be, so don't get overwhelmed by what you're about to see, is the nitrogen cycle. So nitrogen is really, really fascinating because it comes into the soil in so many different ways. Right, so we talked about how you might have nitrogen fixing bacteria living in legume root nodules. You might have, right, poop and other dead animal material coming from any number of different animals. Lightning, which is something I love about nitrogen, is that there's something that happens in lightning that helps you get nitrogen into the air and into the soil, which is so cool. And you have all of these different cycles, right? So nitrogen can be in an ammonium form, NH4+. It can be a nitrite, NO2-. It can be a nitrate, NO3-, right? It can be in any number of these different forms, and all of these forms behave slightly differently in the soil, do slightly different things, and only kind of this nitrate form is really easy for the plant to take out, for it to assimilate, right? So if it's in any of these other forms, the plant's going to have trouble seeing it. Sidebar of something that's kind of interesting about nitrogen is because the nitrogen cycle is so complex and because there's so many different ways for nitrogen to exist, North Carolina Department of Agriculture doesn't actually test for nitrogen on your soil test. And that's because like they just don't know how to catch it at just the right time, right? Like it's just not worth the effort when instead they can say, we know you probably need about this much nitrogen to grow the plant you want to grow. Because as you can see, the nitrogen itself is bopping around in a million different ways. So we know there are these plant nutrients that are super important, but we also know they have to be in the right form for the plant to be able to see them. Part of what's also interesting about this is that pH can really affect whether the plant can see a nutrient or not. Right, so this is like one of my favorite graphs because I think it's just so cool. What it shows is basically here's pH along the bottom. And these are just different words, right? For a pH under 5.5 is strongly acidic, a pH above 8.5 is strongly alkaline. And if a bar is green and white, it means that it is available. Yellow is less available, red means it's unavailable, right? And so a lot of our native soils are somewhere in this 5.5-ish range, if not even sometimes lower, right? And you can see there are all these nutrients in here, right? In this red area, right? These are not easily available for plants. And so we'll come back to this. Some of our native plants have adapted ways around that, but many plants can't quite figure out what's going on with our low pH soils, and they can't see the nutrients they need. And so oftentimes you'll have recommendations to add lime to our soils. And that's really to push you up into the 6 to 6.5 range. This is kind of the golden target range where you have enough things that are green or yellow that it's more or less good for plants. You might, in a perfect world, want to go even a little bit higher than that, but it's hard enough to get our soils happily in the 6 to 6.5 range that you're kind of like close enough for horseshoes and hand grenades. So this is typically the recommendation you'll see. Something that's not shown on this graph because it's not an essential plant nutrient, but it's fascinating, is aluminum. Aluminum down below 5 or so, which is where a lot of our soils are, aluminum goes from being just in the soil and being around to being toxic. And so what's really cool about this is like, this is a healthy plant root, and this is a plant root that was grown with too much aluminum around, right? So this is aluminum toxicity. And so what you can imagine is that if you're a plant that's not used to seeing these high levels of aluminum, and you haven't evolved adaptations to get around that, you are going to get walloped by the aluminum in our soils, right? Because it's going to, especially when they have those low pHs, and those plants are never going to do quite as well, because not only are they not getting the nutrients they need, but they're also being actively damaged by some of the chemicals in the soil that are at such a low pH, they become toxic. So you might think, oh my God, I need to know my soil pH. How do you know? I don't care how good a farmer is, he can't tell by looking, right? The way you know is by taking a soil test. So luckily here we have the North Carolina Department of Agriculture Soil Agronomy Lab, and they do really, really nice little soil tests. That's kind of basic, but it tells you all the chemicals or all the nutrients in the pH, and so kind of the basic information you need to know. And so if you want to go out and do a soil test, I'm just going to walk you through how you do this in case you've never done it before. You look at your yard and you separate your yard into what I like to call areas. So an area might be someplace like your front lawn, your vegetable garden, your trees and your shrubs, your back lawn, right? It's not the whole thing all at once, right? An area is basically any space that I would say has been treated different historically, right? So you probably treated your vegetable garden different from your front lawn, or that you plan to treat differently in the future, right? So if I was going to add another vegetable garden in my lawn and I was going to add it right here, I might sample that area separately. Or any two areas that you can just look at and you're like, the soil looks different, right? Like this area is super wet, that area is super dry, this area is dark, that area is light, right? Those you also separate out. Take multiple subsamples per area, about 6 inches deep, right? So this person kind of marches along and takes a sample at each little spot. You put them in a bucket, you mix them up, and then you get your super handy soil sample box, you get your soil sample form, you fill it up, and the soil samples are free for testing between April and Thanksgiving. And you can even drop them off here at the Cooperative Extension Office at 721 Foster Street. Starting in April, we have a blue cabinet on the north side of the building where you can get both supplies and also where you can drop your samples back off, and we will take them over to the lab for you. If you're thinking like, I just can't wait, the rest of the year, Thanksgiving to April, soil samples are the exorbitant fee of $4 a piece, right? They are not expensive. They just like for you to do it in summer if possible, because most of the farmers do it in the winter. And so they're trying to encourage folks to do it, kind of homeowners to do it kind of in the off season. Once you have submitted your soil sample, you'll wait a week or two, you'll get your results back, and they might look like Greek. But I'm going to talk you through how you interpret this. So this is what a typical soil sample report looks like for a home gardener, right? Your results will look slightly different than they would for a farmer, but they're pretty easy and straightforward once you kind of know how to read them. I always joke that the North Carolina Department of Agriculture did a really great job putting together an easy key on how to read these. They just didn't tell anyone what it was. So the first thing you're going to look at, this is for a single soil sample, right? And you can tell, so as we were doing for out front at the office here, we wanted to grow a flower garden. That's why it says crop 1 there. That's the other really cool thing about our soil samples is not only do they take your soil and tell you what you have, but you get to tell them what you want to grow. So they tell you how to grow what you want to grow on your soil, right? They give you that specific of a recommendation. So the first thing here is the pH, right? So the pH of this soil that was in the sample is 5.4. Remember, that's a little bit low. they're saying we'd rather you would be at a 5.8 to a 6.5, right? See, this bar doesn't get into that optimum range. And so what you can do is you can add 40 pounds per 1,000 square feet to that soil to get the pH into the range you want. There are two different types of lime that are available. There is what's referred to as calcitic lime, and there's dolomitic lime. Calcitic lime has calcium, dolomitic lime has magnesium. Buy whatever you want for the most part. It's fine. You can see down here, I just noticed our CEC is 12.6, above 10, woohoo, right? So that's the first one, the lime recommendation. If I could only do one thing off of the soil test, I would do the lime. I would get the pH right, and that is because, remember, pH affects nutrient availability. So I can keep dumping and dumping and dumping nutrients, but if my pH isn't right, it doesn't work. If you live in an area with recent construction or where other crazy things have happened, you might actually have a pH well above 7, right? And so you don't use lime in that case, you use sulfur products to bring your pH back down. Pretty straightforward, totally doable. If that's the case and you are like, Ashley, walk me through that, let me know and I can help you figure that out. Once you have your lime right, then you want to think about your plant nutrients, right? So like I said, they're going to tell you phosphorus, they're going to tell you potassium, they're not going to tell you nitrogen because it bops around in the soil too much, it's hard to test. This is this easy key that they devised, but they didn't tell anyone. So you'll see it says phosphorus index, potassium index. An index value means that that's not like an actual value, it's a value on a scale. And the scale is 0 to 25, basically, oh my God, add more, you need more. You do not have enough. If you have a number between 0 and 25, add more, just do it. 25 to 50. You will see a marked improvement if you add more, like it'll be better. 50 to 100, you have enough. Don't need to add more, keep an eye on it. You want it to be somewhere in like 75, right? Over 100, you have this in abundance. You're not going to see any benefit from adding more. Just cool it with whatever that was for a while, right? Oftentimes, if you've been adding compost for a long time, you might have phosphorus and potassium numbers that are significantly higher. It's probably fine, but just, cool it for a while. So you can see here our phosphorus index is at 54. And so that is within the optimum range, whereas the potassium index is at 41, right, which is below that 50 to 70 optimum range. NCDA will often say 50 to 70. Soil scientists that I've spoken to have often say 50 to 100 for an optimum range. But you can see potassium is low, phosphorus is sufficient. And so when they recommend a fertilizer, they recommend something that's got nitrogen because they assume you need nitrogen. No phosphorus, remember phosphorus is the middle number, and potassium because you're low on potassium. So NPK, nitrogen, phosphorus, potassium, yes, no, yes. This I think is quite interesting. I loved that the soil test came back this way, right? Because potassium is low. That is something we would expect given that we have an ultisol. You would expect potassium, calcium, or magnesium to be low. And it just totally comes out this way often that you will see our soils are deficient in potassium. So we'll talk a little bit about selecting a fertilizer and all that, but I just want you to see kind of what these soil test results look like, the sort of information you're going to get off of one of these sample submissions. So that's been a lot of information. We have talked about texture, so the mineral composition, we've talked about structure, how it's all stuck together. We've talked about plant nutrients, nutrient cycling, we've talked about soil testing, we've talked about any number of different things. And so at this point in this talk, if your head is swimming, that happens, right? If you feel like that was a lot of facts, that happens. So I want to take this next little bit to just say, how do you put this all together? How do you put this into application for yourself in your garden? So first off, what do we know? You probably have a compacted clay soil with low organic matter. What should you do? Break it up. Add organic matter. Keep adding organic matter, right? If you want to get from kind of the dry, waterlogged, sometimes dry, sometimes waterlogged, sometimes crazy soil that you have to something beautiful, like what we see here at the Juniper Level Botanic Garden associated with Plant Delights, right? This is in the same sort of soil we have. The folks at the Juniper Level Botanic Garden have just spent decades amending their soil, right? That's how you get this sort of lush area. So what does this actually mean? Let's walk through those steps of breaking it up and adding organic matter. So I like to think of tilling as bringing out the big guns. You're going to want to break up the top 6 inches to even 2 feet of compacted soils. Oftentimes what will happen is that soils will be compacted actually quite deep down. So sometimes in that 2-foot range, where the clay will be so compacted, it's called a hard pan, right? It's almost like just a plate underneath everything, right? And the water can't move through properly. What you want to do is you want to tear that up. This is something that you do once and then you're done. It used to be more common to do tilling more routinely, but a lot of really good soil science and a lot of work from like the Natural Resource Conservation Service through the USDA has shown us that tilling is something to be done quite sparingly. But doing it at the beginning to really break things up, it's kind of like a hard reset, right? It's kind of like just rebooting the whole system. You want to be careful because it does disturb the soil biome and can lead to organic matter loss, so do it very sparingly, right? If we think about all of those worms and germs that are helping you in the soil, they like being in the soil. They like being underground. When you do this and you make underground above ground, right, you churn the whole thing up, that's a massive disturbance to that biome, and you'll lose a lot of those critters. But again, sometimes you need a hard reset. Avoid tilling when the soil is overly wet or overly dry. Be careful to kind of do this right when the soil is kind of in an intermediate phase, otherwise you can cause even more problems. I know I'm sounding a little bit like negative about this. If I was setting up a new bed, especially in a more residential area where I didn't know the history of the soil, I would probably do an initial till once just to get it broken up. There's some really, really, really good value in that. I just wouldn't do it again. The kind of lighter version of this is something like an aerator, right? Like those machines that go in and pull plugs out of the soil, like you'll often do in lawns, that reincorporates air and pore space into the soil, and that's really, really helpful. The one little like caveat I would add to that is that if you're going to aerate your lawn, which is not a bad idea, don't like do it with a fork where you shove down in, or they have these crazy spike boots even where you just like spike along on the ground, right? You actually want the machine that reaches down in, pulls a core of soil out and like throws it on the side, right? You want something that lifts soil out, because otherwise what you can imagine, right, is you had compacted soil and then you shoved a tine down in there, but you didn't pull any soil out. So even though you have an open space, you have even more compacted soil around it, right? Like the soil in the open space had to go somewhere because you didn't pull it out. So use a core aerator if you can. Once you've done your massive reset, you just want to be adding organic matter, right? So a 3 to 6 inch layer of pine bark or compost mixed with the soil. If you think about someplace like Juniper Level Botanic Gardens, that picture I showed you earlier, I know that when they set up beds there, they do something like 25 to 50% compost in every bed, and they actually make these big mounded raised beds. They add so much compost, and that's really nice, right? Because even though that seems like you're adding a lot at the beginning, as we know, that compost breaks down quite rapidly, so it'll be lost over time, but it'll settle into the clay and it will kind of improve the structure of the area. Once you have that organic matter incorporated, you keep adding organic matter, right? So keeping your soil covered with a 2 to 3 inch layer of mulch is a really great way to not only protect the soil biome, but to continually be adding organic matter, right? So if you mulch every year you're adding organic matter, right? It's not like you mulch and then you come back a year later and the mulch is still there, right? It's degraded, it's broken down, it doesn't look as good, right? That's because it's all being broken down and being incorporated into the soil. And over the course of even just a couple of years, if you are mulching regularly at the top, even if you were unable to break up the soil below, if you were to take a soil probe and just go right down into that soil and grab like a snapshot of the side of it, you would see organic matter starting to be incorporated down into the soil, right? Because it's breaking down, it's washing into the lower levels. Another important note, just while I'm thinking of it, if you can put paths in your garden so that you're walking on paths instead of walking on beds, that's always good too, right? Because you put in all this work to break up that compaction. You do not need to be what is effectively a large animal walking over that soil, right? So it's always good to stay off beds as much as you possibly can. Obviously, you need to walk on them at least a little bit to maintain them, but to kind of minimize how much you're walking on beds, walking on paths instead. Some of the additional benefits of mulching. It's really amazing because a 2 to 3 inch layer of mulch can help suppress annual weeds. It'll keep the roots cool in the summer. It obviously adds organic matter to the soil. And it's better for trees than turf grasses, right? So a tree that is surrounded by mulch is happier than a tree that's surrounded by turf. One of the cool things too, just if you're into it, is that a lot of, if you think about something like oak trees, which have a lot of good press right now because they support so many native insects, often the caterpillars that like to live in oak trees, they will actually survive for some period as cocoons in the soil. So they actually need to hit basically bare soil or only lightly covered soil, and then they can crawl down in there and they can pupate, right? They can turn into butterflies or moths. So they can't do that on grass. They really need that mostly bare soil, which is kind of cool. One note about mulching around trees is that you always want to leave this area right down here, this area around the root flare, right? That's the area where, or the trunk flare, the area where the trunk flares out. You want to leave it without soil around it, right? Don't mulch up in a volcano, but instead leave that area bare right around it. So you're mulching in a donut, not in a volcano. Just pro tip for those at home. If you mulch in a volcano, it weakens the tree and it can lead to all sorts of like gnarly downstream effects. So those are some kind of, sorry, a lot of talking. Those are some of the basics, right? Of anything that you might want to grow. You're going to want to break up the soil. You're going to want to add organic matter, add more organic matter. But if you want to think a little bit more specifically about what you want to grow and the different tactics you're going to take kind of for different plants, most plants will like increased drainage. Even really kind of boggy, wet plants tend to like actually water that moves through, not water that just sits for long periods of time. Plants will tolerate that, but a lot of them don't actually truly like it. So most plants will like increased drainage, unless you're very intentionally setting up a wet area. This is a good thing to keep in mind. Native plants are adapted to our soils. So once you get organic matter in soil, once you get it kind of humming right along, more similar back to like what it used to be when it was forest, most native plants will be happy. Be reasonable in this interpretation, right? So something that's worth keeping in mind about North Carolina is that a plant that is native to the mountains is absolutely probably not native here, right? So for every 1,000 feet you gain in elevation, it's like moving 200 to 300 miles north from a climate perspective. Why do I say that? I say that because if you go from the coast of North Carolina up to the highest point, up to Mount Mitchell, that is the same from a climate perspective as going from here to Ontario, okay? What I mean is that it doesn't matter how beautiful that mountain plant was, it's a little bit different here. And even though it's native, it might not be native here, right? And some plants will want more well-drained soil, some plants will want wetter soil, some plants will want all these different things. I will send out a link in our final resource page to the North Carolina Plant Toolbox, which is a really, really excellent resource put together by North Carolina Cooperative Extension, North Carolina State University, where they list not only all these plants, but are they native? What pH do they like? What soil do they like? Blah, 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 right? So you can actually figure out that you're using plants that are native for what you're thinking about. Non-native plants and fruits and veggies will require extra work, right? This is something to keep in mind. Most fruits and veggies are not native, right? They are from, for tomatoes and things like that, they are from like the Andes, all right? They're from Central America. For some things, they are from Africa, right? Like they're from very, very different places, right? So just because you have cultivated this beautiful native soil does not mean that a tomato wants anything to do with it, right? Like it, from an evolutionary perspective, has never seen anything like that and doesn't understand why you're trying to put it in clay. So we'll talk that through. Again, starting out for non-natives and for fruits and veggies, get your pH right. So some of our native plants will tolerate these lower pHs. They might even be adapted to these lower pHs, know how to get nutrients that are in these ranges, know how to deal with aluminum, know how to do all these other things. These non-natives and the fruits and veggies don't even know what you're talking about. Get your pH in the right range or get your pH into the range they like. It is always worth knowing whether you are trying to plant something that is happy in a 7.5, right? Because it's just not going to be happy here, right? You can lime and lime and lime all you want, but as I like to explain it, you are adding lime to the earth, right? Like you are adding lime by the bag to a volume that is earth, right? It is going to be hard for you to adjust it too high for too long because it's just it's a larger volume than what you're adding. So you can get a little bit higher, but it'll be hard for you to get significantly higher for long. So, okay, so you know I need to add my lime. You're going to want to apply up to 50 pounds per 1,000 square feet at a time, right? So this is 40 pounds per 1,000 square feet. I could add that all at once. I could just top dress it. And you want to buy the finest particle size you can find and you can afford. Oftentimes, this is something that will be called pelletized lime. It's a very, very, very finely ground lime. The reason for that is that the lime literally has to break down and interact with the soil. So large particles just won't break down in a meaningful time span. Something like pelletized lime, which is very, very, very finely ground, will break down in a reasonable time scale, will actually impact the soil. You can't just do this once. You're going to have to test your soil every 2 to 3 years to make sure you're still in the pH range you want to be in. For fruits and veggies, you're going to also want increased drainage, right? So they want to be up out of our clay soils. They do not want their feet wet the way our clay soils will do. One way you can do this is with rows, with kind of like raised rows, where you mound them up. You can also use raised beds and containers. We're going to focus more on raised beds and containers just because a lot of people don't have space for rows, but rows work fine, and it's a way of using our native soil. But just again, remember, you're going to be mounding up on either side, and you're going to be incorporating organic matter. And it's all to get these plants kind of up out of all that water. So for raised beds, these are awesome. These really, really improve drainage. I'll show you some specifics on kind of how I would set them up. People don't just do raised beds in this area because they're cute. They do them because they have to, right? You have to get that drainage. You have to get it. It's the best thing you can do to keep all of these plants happy. Remember, with fruits and veggies, what we're trying to do is we're trying to grow a plant so that it's so happy it will produce extra sugars, extra structures that we can steal, right? Like it is producing at such a high level that it's producing extra that we can take, right? So you have to really baby and coddle these plants to get them to do that. The other real benefit to raised beds, and these are filled entirely with brought-in soil and compost. It's not native soil. You don't need that native soil, right? These are not native plants. They don't know. You're just trying to give them whatever will make them happy, and it is typically something like a bought topsoil compost mix. Is that in a lot of our native soils, especially in urban environments, we can have problems with contaminants. Right, so we have had with one of the biggest being lead, right? So lead is typically a cation, right? So if you think about lead typically existing as Pb2+, right? That means that once lead gets into your soil, because our soils have a very good cation exchange capacity and because they hold cations, once lead gets into your soil, it's really quite difficult to get rid of it, right? Like it's not just going to wash out. And so because in urban environments, you can have more lead. If you are sensitive to those sort of concerns, I would recommend using raised beds with bought soil. The North Carolina Department of Agriculture's soil test does not test for lead and other contaminants, but there are a number of reputable labs that do, including the one from Cornell. So you can always have your soil tested to see if this is a special concern for you. But it's one reason, especially in urban environments, I would typically recommend a raised bed system without native soil. It can be open at the bottom. Most roots don't go that low, especially if you build beds high enough. So for these beds, you want them to be no more than 4 feet wide. The reason for that is just like the very simple, like it's hard to reach that far if you make it too wide. It's hard to get to the middle of the bed. You want them at least 8 inches deep. If you're making it over a hard surface or a surface where you're afraid of contamination, I would make it at least 2 feet deep, even 3 feet deep, right? That's more than enough room for those roots. They're going to be super happy, right? Like at 3 foot deep, you can put this thing like almost over asphalt and it would be okay, right? Like it's crazy, but that would work. 2 feet is a good target though. And you want to fill it with the mix of soil and compost, and you want to be about 75% soil, right? So 3 parts soil to 1 part compost. Even then, you'll have to be adding compost back each year because, again, it will be broken down by our warm, humid environment. But that's kind of a good starting point. Containers are another great option if you don't have enough room for raised beds. They're great for limited space or contaminated soil. Obviously, larger plants need larger containers. And for best results, use potting soil, not garden soil, right? So this is, again, another product you go out and you buy, and it's called potting soil. Fun fact, a lot of potting soils, like especially as you would buy in a bag, actually have no mineral component. So they're not even really considered soils, but like it sounds nice to call them potting soil. You can reuse that potting soil probably for a couple of years, especially if it still feels okay. And if you didn't have any disease problems, like by feels okay, I mean like it's not super hard, it's not super compacted, you didn't have disease problems. You'll need to start adding nutrients back in. So you'll need to start adding fertilizers back in. But I would replace it every couple of years. It's not terribly expensive. And you need to use slow release fertilizers. And you have no need to do a soil test here, right? Because you know what's in it. It was written on the bag, right? Like if it had a nutrient component to it, it was written on the bag. So if you're doing raised beds though, or if you're doing maybe say ornamental beds, something like that with non-native plants, and you want to make sure you get it just right for them, what do you do if you need to fertilize? So again, on your soil test, you're going to have that nitrogen, phosphorus, potassium fertilizer recommendation. And so what does that really mean? So these are the three numbers that are always on any bag of fertilizer. It has to be tested, it has to show them. They are percentages. So, right, so on this bag here, you would have 32% nitrogen, 10% phosphorus, 10% potassium. They're always in that same order. They're always in this NPK order. And so if we look back at that soil sample from the previous page, right, so this one calls for nitrogen, no phosphorus, and potassium, right? So it calls for this kind of like weird formulation of a 15-0-14, and you might have trouble finding that. But because you know these are percentages, you can figure out what that means, right? So if you think about something like nitrogen, it calls for 7 pounds of nitrogen per 1,000 square feet at a 15% rate, right? Those are, so I can say 7 pounds times 0.15, 15%. That's a little over a pound of pure nitrogen per 1,000 square feet, right? Which means that if I found something that was like a 10 instead of a 15, right, I can do some math and I can figure out how much of a 10% I would need to add relative to a 15%, right? So it's kind of pretty easy to math those out. It's just a little bit of percentages. And if you ever get kind of stymied on this or you forget like how it works, just reach out to me and I would love to walk you through this. When you're picking a fertilizer, there are 3 major types. There's slow release, soluble, and liquid. Slow release fertilizers release nutrients over an extended period of time. These are really good. These are the ones that kind of like tend to really get into the soil and stay there, which is really helpful. Things like Osmocote, there are plenty of organic options as well. Soluble fertilizers, they are applied as granules and typically broken down with water, like rain. So that's kind of your typical 10-10-10 granule. And liquid fertilizers, these only provide a quick feed and they're only good for a fast boost. So Manure Tea, Fish Emulsion, Miracle Grow, any of those things, those liquid fertilizers, a lot of times they don't hang out in the soil particularly long and they're really kind of like rapid action. And so it's great if you see a plant with obvious nutrient deficiency symptoms. All of the different nutrients have pretty specific deficiency symptoms that you can look up or you can reach out to me about. But otherwise, like these are like candy, right? Your plants don't need that much of them. And don't count on organic matter to do all of this for you, right? So a lot of organic matter, if you look at something like a bag of black cow, that's only 0.5, 0.5, 0.5, right? So there are nutrients, for example, like potassium that we know our soils are deficient in, that no matter how much organic matter you add, if you're not adding the right kind, or if you're not making sure you get that potassium there, it's not going to be there, right? You might still need to add it, and organic matter alone won't do it for you. On the note of organic matter though, right? You can always make your own organic matter. You don't just have to buy a bag of black cow, even though it's kind of fun. There are 3 major types of composting that I'll just touch on very briefly. If you're interested in learning more about composting, chapter 2 of the North Carolina Extension Gardener Handbook is actually all about composting. It's really, really interesting. And I would really recommend checking that out. But so there's cold composting, which is kind of where you just let everything like rot in a pile, right? You just throw a bunch of twigs, everything else like that in a pile. And it takes a couple of years and it's kind of slow and it doesn't kill weeds, but it's also like no input work-wise. There's hot composting. This is kind of the thing you hear about more commonly, where you have really specific brown to green ratios or carbon to nitrogen ratios that you need to add. You want to keep it in a shady area. You want to keep it moist. It's like a slightly wrung out sponge. Like it's a lot more specific with hot composting. And there's vermicomposting, right? This is composting with worms. In all of these types of composting, you don't want to add animal products. So that's like meat, feces, anything like that. You don't want to add diseased or infested plant tissue or weeds that have gone to seed, right? You don't want to add things that like you actively would not want to be spreading back on your garden. If you can't tell from me talking about it, I am a huge fan of cold composting. I think that hot composting and vermicomposting are very interesting. They can be very fun, but they are kind of long-term projects that you need to stay on top of, and you kind of need to know what you're doing. And I am much more of a like put things in a pile and walk away and come back in 2 years and find humus type of girl. Cold composting is easy. I find that most hot composting, when folks stop paying attention, turns into cold composting. So I would just rather be honest and start where I'm going. If you are interested in the other two forms, hot composting or vermicomposting, just reach out to us. The Master Gardeners can help you with information on any of these other methods and give you kind of really detailed, good information. They're both very interesting, both very doable. Vermicomposting means you get to have a tub of worms, which who doesn't want a tub of worms? So there's definitely some merit there. And so with that, I would like to kind of wrap this up, thinking about what our goal is with our soils, right? Our goal ultimately with soil is not with soil, it's actually with our gardens, right? Our goal is to have these beautiful, lush gardens. This is that picture from the Juniper Level Botanic Garden, and this is a beautiful, wonderful space. And you can see here, they have these beautiful paths running through it where they walk. They have these mounded beds with a lot of organic matter incorporated. And the fact that they've spent any number of years working on their soil is what allows them to have this beautiful, beautiful, beautiful display of foliage, of plants, of garden, right? All of this green looks good because the soil is good, right? That's ultimately how they get there. That's ultimately how we're all going to get there. And luckily enough, we have really good starting material here. It just needs organic matter. It's the biggest take home I can give you. Go out, buy yourself a present, buy yourself some compost. Your soil will thank you, your garden will thank you. So with that, I would like to take any questions that we have. And I will also be sharing the link to that survey where you can give us feedback on this talk.
Okay. From Diane, does surface application of gypsum help to chemically create spaces between clay particles for several inches of soil depth, or does gypsum need to be worked into the soil? So can you just spread it?
Yeah, this is like an interesting one because so gypsum, if I remember, is about a magnesium deficiency. You can top dress with that. I would probably mix it in a little bit, but I think either way you're going to be fine. Let me get back to you about that though. If you could get her contact information, that'd be great.
All right. Next up is, hang on a minute. I know there's more. In what setting would aluminum occur in the soil?
It's just a naturally occurring element in our soil. So our soils tend to be high in aluminum and they tend to be high in iron. And so one of the ways, that's just a thing about a highly weathered clay soil, those elements tend to be left after all that weathering. It's the reason, the iron component is the reason that our soils are red, right? That's what gives our soils that bright red color. And if our soils were underwater for long periods of time, they would actually turn kind of a sickly gray look. And that's because it's the iron turning a different color because it can't have access to oxygen. But iron and aluminum are just products of our soil.
All right. So can you talk about what bag soil to buy from the store for Mackenzie? Sure.
I tend to buy whatever's like kind of cheap, to be totally honest. Sorry, I'm like trying to think about this, make sure I answer your question properly. If I was trying to fill a raised bed, I need to buy a lot of it. So I'd buy whatever's cheap. I would probably buy a bulk topsoil product if I could, and a bulk compost product. You can have them delivered, or if you have a friend with pickup truck, you can borrow the pickup truck, get the soil. If I was trying to fill a container, I would buy something that was probably kind of a mid-grade, not super nice, not super not nice. Kind of whatever I was going to afford and whatever looked good, to be totally honest. if the plants are already established and they're like adult plants, you could buy something with a little bit of a nutrient component as well. It'll be written right on the bag. That works pretty well. If I'm trying to buy soil to start seeds in, oftentimes it's good to buy a soil with no nutrient content. And that's because seedlings can be a little bit sensitive to nutrients. And so instead you buy a soil with no nutrient content and you start adding nutrients once the seedlings have come up. But this is not like magic, right? I kind of tend to buy whatever I'm moved to buy at the time and whatever's a little bit cheap. And I would probably throw in a container of like the shaky Osmocote and call it a day. In my purchase, not throw the whole thing in the container. Like I'd add that to my purchase and call it a day.
All right. Any thoughts about using grounded coffee beans from Starbucks? Goran wants to know.
Add them to the compost. I would not necessarily add them directly to my soil because I believe they're acidic, and our soils are acidic enough as is that I don't need to be adding acid to my acid. But they'll be great in your compost.
There you go. That's a great thing to do. All right. We would like to add fruit trees and bushes. What would we do to prepare soil samples for each location?
Right. So you would go and you would take samples from each location, mix them up like we talked about. And the cool thing about, I don't know if this is going to work or not. But so when you have one of these awesome soil sample forms, you get to fill out all this information on the front and there are codes on the back. And I could show this to you more in depth, but the codes basically, I can enter this code 030 on the front and it's for berries, fruits, and nuts, except the blueberries. And that's because blueberries like acidic soil, right? But if I was trying to grow fruit trees and nuts and that kind of stuff like you're talking about and shrubs maybe, that would work really well. And so I could take a soil sample from either, if all the soil in that area looked the same, I could take one sample, or if the soil was in two different areas, I would take two samples, or if like there was like a wet side and a dry side, I would take two samples. But yeah, it's all about just getting the right code on it. And then they're like, oh, fruit trees, got it. Here's what you need.
All right. Rebecca reminds us that Compost Now is a great service. You can not only have them come to your house to pick up all of your vegetable scraps and everything non-animal, but then you can also earn compost that way.
Yeah,
yeah, it's cool. All right, Angie says, I have an area where 2 hickory trees fell and now I have sun hitting it and weeds coming up everywhere and a lot of ivy and other vines. I will get the soil tested, but if it's somewhat foresty area in Chapel Hill, I would like to put native flowers and bushes. I guess I can do spot soil amending, or is it forest flourish space good soil on its own?
I would probably do a soil test anyway. The reason I say that is because even things that look forest to us now might not have been forest 100 years ago just because of widespread agriculture. And so there's a lot of stuff in this area that is actually extremely highly disturbed, even if it doesn't look it, right? So I might do a soil test just to know what I'm dealing with. I would certainly be adding organic matter. You can do spot amending as you want, but just as much, honestly, as much as organic matter as you possibly want would be great. Yeah, Osmocote is it's a granular, like this big fertilizer. It comes in like a shaky container, almost like Parmesan cheese, but bigger holes, and like craft Parmesan cheese, and it's not real Parmesan cheese. And so it's one of those great ones for houseplants or anything else you might want to shake some fertilizer at. Kind of easy and kind of somewhat slow release, which is nice.
All right, that was the last question.
Easy enough.
And you need to mention your survey, dear.
I did, I think.
You put it in chat. Did I miss you talking about it?
Oh, no, yeah. Oh, yeah, no, I'm on it. I talked about it. There's a feedback survey. It's in the chat. Take it.
Okay.
And I'll send a link to that as well when I send the link for the recording of the talk.
All right. Well, there's the deep dive you all wanted to hear on soil.
Yeah, and so we will hang out a little bit longer in case you want, but yeah, I think we're good. Thanks, Monica.
Well, you're more than welcome. Thank you. I think that even if you don't know how to use all the information that you mentioned, that everybody learned an awful lot more than they knew about the soils that we are walking on and looking at every day.
I just love the fact that it's just the sloughed off Appalachians, or that we used to be like Japan until we collided in.
Yeah, no, that is all cool. I didn't realize that the Appalachians were that big, and now they've just ground down to what they are, and that's pretty fun.
They used to be like the Alps.
And they were that, and that they're that old.
They're like the oldest.
That's amazing.
Yeah, they're really cool.
Ashley?
Yeah.
Oh, hi. I typed in a question, but I think it was missed. I had a soil question for you. The question is, I'm going to actually read what I wrote. I have some fruit trees that I planted about 2 years ago that are still alive and doing well. And when I planted them, I dug a deep hole, and instead of refilling it with what I know is clay, I refilled it with a mixture of topsoil and compost.
Mm-hmm.
So I'm wondering, is it enough to just do a yearly fertilizing, or should I actually keep adding organic matter around the base of the tree every year? Because like my soil is straight up clay, and I know that. That's why I added in topsoil and compost.
So what kind of fruit trees are they?
Peach trees.
So I would keep adding organic matter. Peach
Okay.
trees like good drainage, and so anything you can do to kind of improve that soil structure overall, right, is really, really helpful. You know, I mean, it's like you can like almost mulch with compost, right? And that's not hard to do. And I would probably do something like that, just to kind of keep them healthy and happy, and just keep an eye on them, because they might get kind of like persnickety if their feet are wet for too long, because they're in clay. But just something to be aware of.
Ashley, I also wanted to ask a quick question. Thank you so much for this presentation. It was super helpful and really well done. I recently moved to my house, and this is the first like spring, summer. And so it's kind of the time to hit the landscaping and try to help the soil. It's just really crappy. And there's also very few plantings on the property in general. And so what would you suggest to do from like the very beginning? So I'm hearing soil testing, maybe till some garden beds that we're interested in using. We're going to add, or we are currently adding raised garden beds for vegetables, but any other tips?
Yeah, so I think that all sounds about right. Do you have, just because a lot of Durham is like this, do you know, is your yard always sunny? Is it partially shady? Is it?
It's partially shady, I would say.
Do you know where that shade is? This is going to sound like a crazy question, but do you know where that shade is?
It is such an interesting question. I don't know how to answer that question. I have a very large tree that is on the west side of the property.
Okay, so if it were me, and if I had just moved into a new property, and I hadn't been there for a full year yet, and you haven't been there for a summer yet, have you?
Let's see. I was here last summer. Yeah. Sorry.
I would spend some time watching the shade in my yard over the course of the year, just because the angle of the sun changes throughout the year, right? And so you'll have spots that were sunny for long periods of day that are now you'll have areas of the yard that are now shady for long periods of the day that in the summer might be sunny.
Mm-hmm.
Right? And so all these things you're totally thinking about are right. You know, I would say adding organic matter, making sure any bare soil is covered. If you know you want veggies, adding raised beds. If you know you're gonna have full sun, if you tilling all that. But I would honestly spend a large part of time like watching.
Okay.
Like, how many hours of the day is that spot in sun? Like, I want to plant beautiful flowers, so I'm gonna say it's 8. Right? Like this is my approach to gardening. It's like it's all 8 hours. It's 10. It's 15 even, you know, and it's like it's 2.5.
8 hours and cross your fingers.
So, you know, because it's kind of like sun and soil are the two that you got to get moving together. So I would take some time. Like, I have a new place too, and it's like my goal for this year is just wandering out at least once a month and taking a picture at 8 a.m., noon, 4 p.m., 8 p.m. Right?
Yeah.
one day. So I just know what I'm actually talking about, because otherwise you will just plant what you want to plant.
And lose a lot of money.
Yeah, middling results. So that's what
Actually, Ethel wants to know, she said she was told that a dead fallen tree on your property would decompose into a matter which is too acidic to use.
Nah.
Yeah, the leaves definitely can bring the acids up. Pine straw can bring the acids up, but hardwood mulch is such a great thing that I can't imagine any tree bark, cambium and everything else being super acidic.
Right, that decomposition is quite good. The one thing that can happen is if you have organic matter, mulch, anything like this that's not aged or decomposed a little bit,
Oh yeah.
what happens is that when it hits the soil, it's not aged, it's not broken down at all. So all those microbes like lose their mind because they're so excited to eat it because it's a fresh meal. And what they do is they're eating it because they really like the carbon, but they need a certain amount of nitrogen to power their little bodies. And so they basically go scrounging around for nitrogen, and they use so much of the nitrogen that's around that they can actually make that area nitrogen deficient for everything else. And so that's
Wow.
why oftentimes, yeah, that's why you'll hear people say, like, don't use fresh wood chips, use aged wood chips. And it's just because the fresh wood chips can actually lead to a nitrogen deficiency. And it's because all of the little microbes are like having a carbon party that they just incidentally have to have nitrogen for.
Right.
So that's the only
Not
thing
to
I can do,
mention-
but it shouldn't make it acidic.
Burn them up with the heat. All right, dear, it's 8 p.m.
Yeah, I have one question,
Yeah.
or maybe multiple ones. Thank you for good presentation. So I started I stopped doing outside or dirt anymore 2 years ago because it's too warm, it's too much sun, too little sun, or whatever. So I started to do hydroponics instead.
Yeah.
For a lot of plants. So it's the same nutrient thing you have to think about, right? It's all
Right.
everything. Have you thought about doing a class on that one? I would love to have a class with that one. We talked about it before, right? We just
we have. Yeah, I will admit,
Yeah.
I'm just not that fluent in hydroponics.
but we maybe can find somebody that is. We maybe can find
Yeah.
somebody that is, because I think in this climate down here with the soil we have, I actually grow spinach, arugula, and lettuce inside year round.
Yeah,
So I
yeah,
always have
no,
fresh.
I know that, like, that's what a lot of the.
Yeah.
Yeah. a lot-
I stopped doing it out because we have 4 or 5 seasons, right? You have to have cold season, but we have to have warm, too complicated for me. So I do it inside with grow light, but I also keep track of pH and nutrient. That's the big thing. But
Yeah,
I think
no, I'm
it's
sure.
very helpful for everybody with that struggle with, and I always going to do my tomato plants and my Chinese peppers, big ones. They're going to be in a hydroponic solution outside on my porch this summer.
That's crazy. I mean, that's the thing, right? As long as plants get those 17 nutrients, they don't.
That's actually right. It doesn't matter how you get them, but you can see the root color, they're very, it's very interesting. I've done it for 2 years. It's
That's
very interesting. And I
Well-
think that's what things are going for people that want, you have an apartment, what you have, right? You can have like a steel cabinet or something with some grow lights in, and if you just manage it right, you can have veggies year round, no problem. So I just think it's an interesting things to have to show people here in North Carolina, in the area we are, Durham and Cary, where I am, right? It's possible.
Yeah.
And I think your channel could be a good one to get that out.
Well, I'll ask around. I'll see if we have some hidden hydroponics experts.
Yeah, do that. And then, I can maybe add my expertise to this as well. I think it's more like, it's not a science expert, more like, what does a home grower want to do if you want to do lettuce and salad and stuff in a hydroponic? What should you think about? I think that's really what it's about. How do you get started? What is the fall? So what do you do? Like, I've gone through a lot of things that everybody else try and think. What should you think about? I think that's what it really is about.
Yeah.
I think that's very interesting.
Absolutely. Yeah. Oh, okay. Sorry, Monica, you got that one.
I did.
Okay. All right. Yeah, Diana, Monica's got you. You're good on nitrogen. It's just that it's that brand new stuff, right? Just ground off the tree. You got to be a little bit wary of.
Well, and it's also too hot to use.
Right, right,
You know,
right.
it's got to bake for a while and burn all that off before you start putting it around your plants. Otherwise, you're burn them up.
Awesome.
All right. If that's everything everybody has, I think that we're good.
Thank you so much, everyone.